Hello, this is Mike at GameFromScratch, and today we're going to look at audio programming in LibGDX. Basically what that means is we're going to look at how to play sound effects, background music, and even record your own audio. In this particular tutorial, I'm going to assume you already know how to create your own projects. If you don't, go back and refer to an earlier tutorial. I've gone ahead and I've created the three that we're going to be using through this video. First one we're going to jump right into is the sound effects. And this is going to be a matter of simply loading and playing a sound effect in the background. I've already got it loaded here for us to save a bit of time. Just like dealing with sprites and graphics and such, when you're dealing with audio files, you put them in your assets folder of your project. Once again, if you have an Android project, it goes under the the asset subfolder of Android. If you do not have an Android project, they go in the subfolder assets in the core module. In this case, I do have an Android project, so we can put our assets in there. Now, the catch is we actually need some kind of an audio file to play here. LibGDX supports 3 different file formats. Each have their strength and weakness, and there's a lot of complication here. It's a bit of a pain in the ass, I'll be honest up front. The 3 main formats are WAV, WAV files, OGG format, OGG files, and MP3. Now, OGG and MP3 are both compressed long-form audio files. What that means is they take up a lot less space, however they take up a lot more CPU to actually decode them. On the other hand, a WAV file is basically just a raw waveform stored in memory. To explain a bit better what that means, let's imagine for a second that a waveform looks something like, there's a bass line, and you've got your sound wave. Mono channel looks something like this. There's your simple sound wave. And then what happens is, what you're doing is you're storing this value over and over again. So the height of the waveform. In LibGDX, they're actually shorts stored. Now, a short data type is able to store any value up to 32.767, somewhere in the neighborhood. So a short value can be anywhere from 0 to 32.767. So this waveform, if you were down here, you would be a 0. Up here, you would be 32 something, 32K. And all you really do is for each sample in a waveform, you store the current value of the wavelength as a short. So what you've got, the first one, the second one, the third one, as you're going. And generally, it's the sampling rate that matters. So CD quality auto is 44.1 kilohertz, which means 44,000 times per second it's sampling this data. So you have 44,000 short values that all go together to make up a waveform in memory. And that's basically what a wave is. It's an uncompressed array of waveform stored as short values. Now, that's a mono wave. So in other words, if you have one channel, it's stored like that. Now, if you're in stereo, you've actually got 2 waveforms, and what that then means is that you've got an interleave. So you've got the first value as a short, the second wave as a short, the second value of the first wave, second value of the second wave, and so on and so forth, encoded. So basically it just doubles the size. So a raw wave file is a waveform represented as just data. MP3s, on the other hand, are encoded. Now, let's go back to our project for a second. We need to have it be either WAV, MP3, or OGG. Catch here is OGG is not supported on iOS devices. Pain in the ass. Hopefully this changes at some point in the future, but you simply cannot use OGG on those devices. On the other hand, MP3 can be used everywhere, and that's lovely and good, and what we're actually going to use in this example is MP3s. Now the catch is, and I'm not going to get into it in detail here, but the MP3 format itself is patent encumbered. That means that the MPEG group actually owns patents that they license out for the use of MP3. And technically, if you use an MP3 in a commercial project, you have to adhere by their licensing, and that can potentially mean paying them money. Now, there are some people that say only tool makers have to do that. Some people say, no, content makers have to do it, and it's very ambiguous. I've never actually heard of anyone being sued. However, if you're in a certain environment, especially if you're working under a pure open source license, you may not even be allowed to use MP3 in your distribution. So for the 99% of us, it's not going to matter, but do be aware there are some legal ramifications of using an MP3, and it's probably in your best interest to look into it a bit further. So in summary, Wave works on everything. It's the biggest size, least CPU usage. The MP3 and OGG formats, on the other hand, are encoded, so much smaller size, but they need to be decoded, which means higher CPU usage. And again, OGG is not supported on iOS. So if you want to support iOS, that means you cannot use OGG. All right, so that's the basics of it. Now let's go ahead and actually get some form of audio file here. And the first catch we've got is we've got to get one. And I kind of spoiled it when I tabbed off before. Where I get everything from is a site called freesound.org. It's free to sign up, but you do have to sign up and register. And then you can come in here and find various audio files. It's sort of like open game art, except for audio and sound files. And it's a great little resource. So here's the sound file we're going to use. It's just the sound of breaking glass. Go ahead and download that. And then what we're going to do is we're going to save it to our project. This is boring to watch. Just a sec. Okay, locate your project in your assets folder and save. Unfortunately, because I'm using a download manager, I can't simply rename the file. So now let's go over to our editor, to refresh. All right, here and hit synchronize. I did something wrong here. Let me just check the file location. Put that up. Okay, for some reason it did not save. Let me just go ahead and download that again. Skip you. All right. Okay. This is going to be a challenge coming up anyway, so let's deal with it right away. The audio file I just downloaded was in FLAC format. FLAC format is very raw, high definition storage format, and generally you would record your audio assets in FLAC, but you would definitely not distribute them that way. Now, this is one of those things we're going to have to deal with regardless, so let's go and look at actually converting that to a different format. And in order to do that, you're going to need a tool, and there's a wonderful one out there. It's completely free, called Audacity. Go get Audacity. It's available at audacity.sourceforge.net. Again, completely free product, and it's amazing for manipulating and converting files, audio files such as this. So go get this guy. It's what we're going to use in this tutorial. So now that I've got that, I'm going to go ahead and open my file, which I saved somewhere. Oh, in the downloads folder. All right, so here it is. And I'm just going to go in here now and export it. We want to save it into our sound effects folder, into our assets called glass break.wave. All right. So as you can see here, as I was saying, there's your waveform data stored raw. And as you can see here, there's two channels. They're identical. And this is actually going to come into play in a little bit. So remember that. I'll actually leave this guy open up in the background here. So the key thing is, and you don't have to do anything like that. You don't do any of that if you have your own assets already. But if you need to go get them, freesound.org is a great location. And if you need to convert it, Audacity can easily do it. But ultimately, all you need to do is get your WAV, MP3, or OGG file and put it into your assets directory like so. So now let's go ahead and start looking at the code now that we have that file there. Now that is located in, oops, I'm in the Android project. Our core, our assets, like so. The first thing we want to do is pretty much strip out everything. This is an audio-only segment we're going to do. No need for graphics or anything else. We're going to do all of this tutorial in the Create section. First things first, though, let's declare our sound file, just like so. And now we got to create one. Creating a sound effect is as simple as gdx.audio.new sound, and then just like with graphics, you pass in a file handle, and this one we called glassbreak.wave, like so. And to play it, just go sound.play. Now, one thing to keep in mind here, and I'll do it down here, dispose. Sound, all the sound, everything we're going to deal with actually today is a disposable item. So as I said in the previous tutorial, if it implements disposable, you got to get rid of it or you will leak memory. Now in this program we're actually going to run, play it, and then exit, so you really don't have to delete. But any of these disposable objects, go ahead and dispose of them. So sound and music and audio device are all going to be disposable, so make sure you get rid of everything that we deal with today if used in an actual game environment. So otherwise, there we go. There's our simple sound, and then go ahead and play it. And let me run this, and we should just hear glass breaking. There you go. So there's your first audio program in LibGDX. Next up, let's explore a very simple concept here, but very important to understand. You have your sound file, which is one of the sound class. The key thing to understand here is you have a sound, but you have multiple instances of sound. So each time, let's say you have like a gunshot, each time you do sound.play, that's creating a new instance of a gunshot. You still only have the one sound object in memory. So here, let me go ahead and show you how that works. When we did play, it actually can return an ID, like so. And then what you can do is once that audio file is actually playing, you can manipulate values of it. And we can kind of show two things at once here. If you do something to the sound object itself, it does it for all instances of that sound. Whereas if you use the particular ID or the instance ID and then set that value, it will only affect that particular instance. So if you've got 30 gunshots going, and at the sound level, let's say you set the volume, like so. Oh, sorry, that won't work. If you want to pause it, that will pause all instances of that sound. Now let's go back and use our ID instead. And what I want to do is take this particular sound and change its volume. We'll increase its volume up. In order to do that, you probably just saw a bit of a preview in there. Let's just go to sound.setVolume, and then you pass in the ID you want. Oh, here, sorry. Let me kick you into presentation mode so it's a little bit easier to see. There. So you set in the ID of the thing you want to increase the volume of, and then you pass in the new volume. So 1 is full volume, 0 is no volume. So now we've increased our volume to full. Actually, we were at full before, so let me just make it really quiet instead. I don't even know if that'll be audible, but so now that instance will play very quiet. There you go. Hopefully you could still hear that. So that's how you set the volume on it. Now there's a couple other properties you can manipulate with the sound. Those are pitch and pan. So first let's look at pitch. Pitch is the speed that it's played at. So you play it twice as fast, it will play back twice as fast. If you set the pitch back to half, then it will play back at half speed, like so. So let's go ahead and play this back very slowly. It's the same deal. You pass in the ID, and then you pitch you want to play it. So we'll play our breaking glass in slow motion, like so. Now let's go ahead and run that. And there it is running very slowly. Same idea. We can turn back and speed this up to double. Okay, there you go. Now the next one, and this is a bit of a catch, is panning. And panning is the left set pan. Pan is your left and right channel. So if you're used to like the sound effect of a plane coming in from the left side and then going out on the right hand side, that would be the panning that's done it. And it's done like, again, you set in your value, and then the value you send, so you send in your ID, but then the value you set in for pan is actually going to be a value from -1F for far left to +1F for far right. And you pass in your volume as a requirement, unfortunately. So there you go. There's your simple effect for panning, and this should, in theory, play only on the right channel. Now there's a couple of catches here. I have no idea how Camtasia is actually recording audio here, so if it's not on the right side for you, it could actually be how this is being recorded. I think it should be recording my computer in surround. I'm not 100% positive it will. So if none of this actually left or right makes sense on your end, it might be a product of the sound recording. However, in this particular case, it's going to be for a different reason. So this, in theory, should only play in your right ear. In reality, it's going to play just like normal. There. There is no effect of the panning. And the reason for that is, and the reason why we kept this guy going, you can, oops, where did Audacity go? Here we go. You can only set panning in LibGDX for sounds that are recorded as mono. You cannot use a stereo sound like we have here. Again, Audacity to the rescue. If you want to do something in mono, you can simply come in here, go to tracks, and just go stereo to mono, and then boom, now we're down to one channel, and then we'll go ahead and we'll export this guy to our project. Like so. And we'll call that glass break mono. And we're done with Audacity, so no saving. Back to our project. Let me get out of presentation. Oh no, actually it should just be there. So I'll just change out the file name to the mono, and now it should just run in the right ear. And on my computer, that was in the right side. If it wasn't on yours, either you don't support stereo or I'm not actually capturing this video capture in stereo. At the same time, so if we want to do the left ear only, let's do far left only and run. That should have been in your left ear only. So that's how you do panning. So those are the three things you can do with a sound effect. Is you can do set the volume, set the pitch or speed, and set the panning or position. One thing I didn't show is instead of actually using the ID after the fact, you can do all of this in the play call. So let me just get rid of everything and instead just go sound.play, and then as you can see, you can set volume to full, pitch to middle, and pitch to normal, and then pan to middle. So this has the effect of, well, basically doing absolutely nothing. It'll play it as if we didn't pass any parameters in, like so. So you can bundle it all into one call, or you can call the three things separately. So those are the three things you can do with a sound effect. You can pitch, you can pan, and you can change the volume. Another option you have, and it's the same thing as play. For every instance of play, there's another version called loop that you could do the same thing. So if we want to use these same parameters, let's go ahead and change play to loop. And you see you can pass in just the volume, or you can pass in all three, or you can pass in an ID and then the other values. So we're going to loop this sound instead. Now, if we call it looped, it's predictably enough going to play the sound on a loop over and over again. You can, all right. Now finally, and we're going to introduce a new concept in this that has nothing to do with audio program, and that is LibGDX timers, which are very handy and very useful for me for doing demonstrations without having to write a whole bunch of code. And basically a timer is just going to schedule something to happen after a certain period of time elapsed. And I'm going to give you a bit of an example of how IDs can be used to control a sound as it goes on. And we're going to take our looping sound here, and we're going to take the ID of it, and call it, say, our sound ID equals. Alright, so there we go. Now what we want to do is go ahead and create a timer that is in 10 seconds. It's going to pause this song for this actual sound instance to stop it from looping. In order to do that, we go into timer, and we want to make sure that we get the libgdx one and not any of the Java or Swing or other guys. So we'll pick it, timer, and then dot schedule, or schedule if you say it wrong. And we pass in a task to that, so new task. And the nice thing is, IntelliJ makes life very simple on me. There's a mandatory override in this class, so it automatically fills it in for us. And all we want to do is just take, let's say, sound dot pause. And we'll go ahead and we'll pass in our ID. So we're going to pause that instance of that sound playing. And let's see, what else do I need to do? Need to set the rest of the timer variables up, which is to say, wait 5 seconds, and that's it, actually. So after, that's all we're going to do. So in this particular case, we're going to, oops. Sorry, I'm using a local, so I need to make it a static, basically. So all we're going to do here is start our sound playing in a loop, and then after 5 seconds isn't long enough to demonstrate it, so let's go with 10 seconds. After 10 seconds, our timer is going to kick off, and it's going to tell us to pause that particular sound playing. So let's go ahead and play this. We should get 10 seconds of looping sound. And right about now, it should go ahead and pause that. There, the pause kicked in. So as you can see, you can pause particular instances of a sound. You can have multiple running at once. And let me just go ahead and show that. This will make it a little bit more effective. So there's the one that we're actually pausing. We can do it at the same time as go. Sound.loop. Let's kick off a completely separate one. And we're going to change its pitch so it's easy to recognize. This is going to be quick, and then there's going to be one in the background that's slow that is the one that's going to be paused. So full volume, our pitch is twice as fast, and dead center. So here you can see we've got 2 looping instances of the same sound running at the same time, but we're going to control only one of them via ID in our timer. So what this will do is make a lot of noise, but we'll have ting, 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 ting in the background. There's the quick one, and then the louder one in the background is running off every few, and after 10 seconds you will no longer hear that. But the quick one will continue to, there, the one's gone, and as you can see, so the second loop is continuing to run. All other instances of sound will continue to run, but that one is being controlled. So you can control them globally, and that's the other thing. I'll finally show that. So instead of controlling the ID, I could have paused them all, and then if I run this one, we'll have our 2 sounds running at the same time, and then after 10 seconds, both will be paused. There you go. So you can control sounds globally altogether by using those, or you can pass in an ID and control a particular instance of a sound. So that's the basics of the. And then in addition to pause, you've also got sound.play and sound.stop. So for your repeatedly used sound effects, the things in your game that's going to happen all the time, bullets, pings, that kind of stuff, you would store the sound once, and then you would create multiple instances of it. However, if you need to track, each time you press play or loop or whatever, it will create a new instance, but if you need to track, control one individually, you store its ID, and then you can set values such as the volume and pitch, etc. after the fact. So if you just have one, you never need to track it. You can completely ignore all this ID stuff, but if you do need to get fine-tuned control over a particular instance of a sound, that's how you do it. Now let's move on to music. Shut this down. Let's close it completely. Let's load up our music project instead. That is in here. And once again, we're going to need some music files. I've gone ahead and I've actually downloaded 2 already. I didn't keep the second one. Alright, I grabbed 2 15-second MP3 files off of freesound.org. I'm just going to go ahead and grab them. I'm going to pause while I do this, but I'm going to go grab them and throw them into our assets folder as Song 1 and Song 2. Okay, here's our code for music all loaded up now in IntelliJ. As you can see in our Android folder assets, we have Song 1 and Song 2. Song 1, alright, I can't play directly from here, but go music, Android assets. Song 1 is simply 15 seconds of piano. Song 2 is this weird guitar, again, about 15 seconds. Right. Again, use whatever MP3s you want in your particular case. There's no specialness to how they're encoded or anything, so basically any MP3 should, in theory, work. So just throw them into your assets folder. Now let's go ahead and read the code. I did it again. All right, let's go back out here. Core, code up, and I'm actually going to remember to go into presentation mode instantly. All right, so first thing is, let's get rid of all the junk. So we don't have any visual rendering. Remember again, everything we're about to use is disposable, so make sure you call dispose or you will leak. So when you're done with something, get rid of it. You're going to find this is actually quite simple. It's very similar to playing a sound effect. Instead of sound, we use music. And I'll just go ahead and create both. I'm going to use them both eventually. And let's go ahead and load both. Loading them, very similar. Song1 equals GDX.audio. Come on. Alright, what did I do wrong? I don't think I did anything wrong. I think IntelliJ is being stupid. Audio dot. Alright, there it goes. Every once in a while, IntelliJ, the current version I'm using anyways, the code preview or IntelliSense just goes incredibly stupid like it just did. So go ahead and load it. I don't know really why I waited. I already know what I need to do. So we're going to load song 1, like so. And we're going through the power of cut and paste. We're going to do song 2. Oops, song at. Alright, oops, that was the wrong key. And song 2. Okay, so there's how you load songs. And playing them is simply a matter of play. Now, when you're dealing with songs, unlike the sound effects, there are no instances. You have one, and that's it. So you don't pass in IDs. There's none of that here. You basically play a song. So if you have to have 2 instances, make 2 separate versions. So the concept of reusable is not really... Well, you can reuse, obviously, but you can't have multiple instances running at once. So there's no ID tracking. None of the stuff we just talked about that way works this way. But here's your simpleness for playing a song in LibGDX. So go ahead and run this code. And our song starts and plays. And really, that's about it. I won't play the entire song. Now, what might happen is you have song 1, and then when it's done playing, you want to instead run song 2. The cool thing is that's built in. What we're going to use is a song completion listener. So song 1 on complete listener, like so, and we'll go ahead and create one, like that. So when the onComplete listener is called when this one is done playing, and then simply all we're going to do is go song2.play. Now technically you could dispose of song 1 at this point if you weren't going to use it again. I'm not going to do anything like that in this particular case, but there you go. Now, unfortunately, we're going to have to listen to 15 seconds worth of bad piano music. But our music will play for its entire duration, and then when it completes, the onComplete handle will kick off, and sound 2 will be played. There you go, and there's their next song kicking in. So that's how you can queue one file to play after another. Obviously in a game... Oh, here, let me shut down the music in the background instead. In a game environment, you would probably have some kind of a manager that you've built yourself. But that is how you can segue between music. Now, the kicker is that here's one of the problems with LibGDX per se. Since it supports so many different backends, it supports HTML backend, iOS, Android, various desktops and such. The audio support underneath is the weak link. If you've done any HTML development, you know audio sucks in the world of HTML. So there's a number of things that can't be done, like what our next example actually just doesn't even work in HTML. There's file format limitations. Some browsers can play MP3, some browsers can play OGG, some browsers can play both, some browsers can play neither. Actually, I don't think there's any that can play neither. But anyways, the backward support, the support between all these different audio systems, it's kind of terrible, and where it kind of gets in is one thing that you would commonly want to do is be able to track your position in audio. And if you use Android's SDK directly, there's a whole lot of low-level audio control. Exact same for iOS. If you use it at the low level, there's a lot you can do. However, in WebGL, or sorry, HTML5, There isn't. The audio APIs kind of suck, and surprisingly enough, the OpenAL audio libraries behind LWJGL, which is the libraries being used to power LibGDX on the desktop, also have a number of limitations. So because of all these limitations across platforms, LibGDX has kind of taken the least common denominator approach. So the support that's built into the music is rather trivial. Like a lot of times there would be fast forward, rewind, tracking, seek, jump forward certain amount, so on and so forth. There's none of that here. You can play songs from the beginning, you can stop them and you can start them, and that's about it. So if you need to, like, say, dynamically jump to a certain point in a song, this is actually quite complex with LibGDX, and you'll have to do it on a per platform basis. So what's there out of the box isn't great. However, you can do things that are slightly more complicated. And here's an example I'm going to go ahead and do. For example, the songs, again, have all the same functionality that sound effects do, so you can pan them, you can change the volume, and so forth. So what would be very common is when you have one song ends, like what we just did, and another one begins after the fact, it's very common to say fade the volume out on the first song. So let's go ahead and look at doing that, and we're going to do it with a timer. Again, and in this case, we're going to do timer, schedule, new, and then create our task, like so. And I'm going to go ahead and check if our song is playing, like so. And if it is, check the location of the song. I know this song is about 15 seconds long. So if the location is after at least 10 seconds have elapsed, like so, then what we're going to do is turn the volume down by 20%. I'm going to do this by getting the current volume, like so, and taking 2 away from it. So I guess that's not technically 20%. All right, so there's, if the song is playing, and if it's after 10 seconds into the song, reduce the volume by 2 seconds. Now we're back to our timer again. And in this case, that's that. I don't know why it's angry. Why is it angry? That might just be my parameters. Next thing we want to do is set a couple values over here. First one, we don't want to even think about running this till 10 seconds, which kind of makes your get position kind of check completely irrelevant, but we'll go ahead with it anyways. And then what we want to do is have this timer run every second, like so. And we want to do it 4 times. So this means after 10 seconds have elapsed, we're going to reduce the sound by 20%, and then a second later by another 20%, and then a second later by another 20%, and then a second later by another 20%, and then at this point the song should end, the next one kicks in, and we've basically faded between the one song and the next. So as you can see, timers are very handy. They are your friend. You don't want to do too much of this, or you can make your code very hard to track through later on, but this is one such example where it's useful. Now let's go ahead and run it. Unfortunately, we're going to have to listen to a few seconds of music. Our song will play. After we get to about the 10-second point, the volume will start dropping and dropping. All right, there we go. Fading out. And then our other song should kick in. There you go. So the actual tools themselves are fairly simple for sequencing songs, but there is some things you can do to get around it. So that's the basics of dealing with music. The one last thing we're going to look at is recording audio. This is actually going to present a bit of a challenge for something I didn't really think of when I wrote the example code. And I'll go into the code first, and then we'll talk about the problem in a second. All right, so let me just minimize this guy. We'll exit out. And we'll load up our next project. And so here, all we're going to do is we're going to look at recording some audio and then immediately playing back. Now, where this is going to present a challenge for me is I am currently using my microphone and playback for recording this video. I imagine in Windows there's an exclusive lock on a microphone, so I don't think I'll be able to record audio while I'm recording audio. Trust me though, the code we are going to write right now actually does work. But in this particular case, I may not be able to actually demonstrate it to you because, as I said, my mic is in use. So the code to run a mic may not work right. But we can try it. And again, come in and we don't need any assets in this case because we're going to create our own. So we just need to modify the code. So we go back into presentation mode. Again, no need of any graphics. As I told you earlier, this particular logic does not actually work in the HTML5 backend. This should work on iOS and Android, however. And all we need to do, first off, we need to create something called an audio recorder. Just need first helps to spell it right. So like so, we'll call it recorder. And then new, oh, my bad, GDX, auto. This is getting kind of predictable at this point. Auto recorder. Now, it takes two values. First off is the sampling rate, and the second is it mono or stereo? If it's stereo, it's going to have the two channels, take up twice as much room, higher processing power, etc. But it can have positioning power, positioning data in there, so you can have left and right panning. Without that, if it's just mono, you cannot. In this particular case, we're actually just going to do 44 kilohertz, which is CD quality, which is also that value right there, and we're going to say yes, it is mono. So each second of our audio then will be 44,000 shorts long, which is a very strange thing to say. All right, so there's our recorder created. Once again, recorder is disposable. Make sure you get rid of it at some point if you're actually using it in real life. So next up, we need our array to actually store the raw audio data in. Call it audio buffer equals new short, and we need it to be 44,100 per second. We're going to record 5 seconds of audio like so. So, like that. There is a buffer for 5 seconds of 44 kilohertz audio. Next, we simply read from the recorder via that. Pass in our buffer. Offset, which is the position to start from, almost always going to be 0. And then number of samples is going to be your audio buffer's length, like so. So that line there will read in the audio buffer's length worth of audio into that buffer from the microphone. So now that we've got it, let's go ahead and play it back. In order to do that, we're going to go ahead and create something called an audio device. Call it very poorly. Actually, let's use that second name, much better. And this should be predictable again. This new audio device. And to an audio device, you set, again, sampling rate and mono or not. Once again, audio device is disposable, so make sure you get rid of it as well. Now, to write the raw data out to your sound card, all you do is go audio device dot write samples. You pass out your audio buffer, offset again, and then audio buffer's length. There you go. So this code right here will record 5 seconds of audio from the microphone and then immediately spit it back out. Everything here needs to be disposed except the audio buffer itself, which we'll get rid of when it goes out of scope at the end there. Finally, I'm just going to do one last thing. I'll show you this. If you want to exit your application when you are done, you can just throw in a line called gdx.app.exit, and the minute it is done playing back, your code will shut down. All this said, I'm about to hit play. I've got my microphone in use. It's going to probably throw up on us, but let's see what happens. Let me get out of presentation mode. I'm done writing code anyways. Run. Okay. View. Exit. Now run. And okay, so it's up. In theory, it's recording audio as we talk. And then okay, so it's up. In theory, it's recording audio as we talk. All right, I'm actually kind of impressed. There you go. 5 seconds of audio recorded and then immediately played back. So that's about it. So in this particular case, what we saw is we saw the sound effects. Sound effects are used for in-memory, used often, quick sound effects, appropriately named. You can track an instance, so you can have multiple versions of the same sound running at the same time. And then there's music. The big difference between music is it streams out. It's Generally, it's MP3 or OGG format, and those are encoded, so they take higher CPU but use up lower memory. Again, remember that the OGG format is not supported on the iPad, and you should look into the MP3's licensing issues. You should do that anyways. It's an interesting topic. And then finally, for audio recording, it's quite simple. You create a buffer, you send it in, you record however long you want, and then playing it back is a matter of writing those samples back out. So that's audio programming in LibGDX. I hope you found that interesting. Thanks a lot. See you next time.